Hey Maxwell, how are you?
Hello, I'm doing very well.
Would you be able to introduce yourself and speak a bit about the topics and the problems that you're tackling?
Yeah, definitely. So I'm Max Tabarrok. I guess my elevator pitch would be everything I write about and think about. It all centers around this one graph, and you might have seen it. It's titled "World GDP over the last 2 millennia." From Our World in Data. It's the classic, hockey stick chart showing economic growth and technological progress over the last 2,000 years. And when you look at the graph, it's flat from year zero to 1800. Essentially, nothing changes. Very little economic growth, very little technological change. And then around 1800, there's this inflection point and it goes vertical, it explodes. And you and I are living right at the tippy top of this vertical explosion, rapid change, accelerating. It almost looks like a singularity type growth. So like we're in a very, very strange world because we're at the top of this massive explosion of growth. And yeah, so just looking at this graph opens up so many interesting and difficult questions. Like, why did this happen at all? Why did it happen in Britain in 1800? Is it going to stop? Can it continue at all, or is it going to hit finite limits very soon? Is it going to collapse? Is it slowing down? What can we do to protect it, to protect ourselves from such rapid growth? And answering these questions ends up bringing in such a wide array of fields. You need economics, but also history and philosophy and science and culture. Um, so yeah, previously I found it difficult to explain like what my blog is about or what I write or research, but I feel like compressing it, it's all about this one graph. That's a good way to explain it.
Awesome, thank you. And yeah, flesh that out. It's about there is no growth for ages. We get suddenly get loads and loads of growth. We're still kind of in that period. And also today, it does seem that that growth, that economic and technological progress, also in some ways might be slowing and actually not being as radical as it kind of has been. So, could you sort of flesh out that part of the story and talk a bit about the question of if our growth is slowing and what that means for us today?
Yeah, so one way to look at this is that um, let me explain it like this. So exponential growth is when you have a constant growth rate. So if, say, your money grows at 2% every year, you gain 2% whether you have $100 or $1 million, even though 2% of a million is way bigger than 2% of 100. You get this, sharp looking curve. It's exponential growth. Now, growth in human population and GDP has been faster than exponential. It's best fit by what's called a hyperbolic curve or a power law fit, which means not only are we adding more and more GDP in absolute terms, but we're also, if you take the long view, we're talking about this zoomed out 2,000 years view. Um, the growth rate itself has been increasing. So the growth rate from 0 to 1500 was maybe 0.1% a year, and then 1500 to 1800 was 1% a year, and then from there it's maybe 2% a year. So the growth rate itself is increasing. Um, and now for the past maybe 50 or so years, the growth rate has been constant at best. Uh, this is still very fast, but maybe that's not quite what we're expecting if we're just extrapolating trends from the past. And then less less quantitatively, uh, there is a sense that some things are stagnating. Uh, you know, my favorite place to find stagnation is looking at like the construction industry. It really just seems like in the Western world, at least, we're a lot worse at building things than we used to be. Uh, Now, these narratives of stagnation were more convincing before this like extremely rapid progress in AI started. So I think it's very likely that this will sort of break us out of our stagnation and maybe restart this increasing growth rate trend that we've seen for the past 2,000 years.
Yes, it's interesting you bring up buildings and some sectors. It certainly seems that, and people have made the case that we kind of build lower quality things or things that are not built to last, say. And so, and we'll get to AI, but I'm wondering what you think of the fact that sometimes we have growth that might, you could argue, be more short-termist. I'm wondering if you could sort of even contextualize to what degree has economic growth been good, or how has it changed us? It's strange because we suddenly get so much of it, right, after 1500, and then it gets even bigger and bigger. How can we understand the shift in our lives, and how does that sort of happen when we look back at, say, 1500?
Yeah, it's a tough question. I mean, I'm pretty young. I was born in 2001, so you know it's difficult for me because yeah, I've never lived, of course, in 1500, but even I've never lived without the internet, without computers. So there's so much that I kind of take for granted because it's literally always been there, but it's like so new. Um, just to give I maybe just a personal perspective on it, like I am doing a job up here in New Hampshire, but my fiance and my family are living down in Virginia, and it's tough to be away from everybody, but with this perspective that I have, like where I'm in this strange position right at the top of this incredible growth curve. Like you and I are, I'm not sure where you're talking from, but we're talking across hundreds or thousands of miles live. I'm saying words, you hear them instantly. I can wave at you and you wave back. Sorry, a ray of sun is,
Don't worry,
but
you're fine.
and that ability is so new and would be just incredible to anyone in the past. I mean, you think if people like went to America and the letters take 6 weeks to go back and forth if you get them at all. And yeah, so that doesn't, I don't know if that really
No,
is,
yeah.
but yeah.
No, it's helpful. And given that there has been such progress, I also was born in 2001, and so it can be hard to even think of a time when there wasn't such sort of ridiculous progress. And given that, and you talked about AI, how can we characterize growth as slowing? Maybe for some people that would kind of sound strange. So you talked about construction. Could we say some fundamental things about the economics or say academia, and just try and help us think about why things might be slowing down despite there still being high growth, but that rate slowing down?
Yeah. Uh, there are a couple of useful anchor points when we're thinking about stagnation in construction. Uh, for example, the Empire State Building was constructed in less than a year. That's just incredible. Like, I remember, there's some routine road maintenance in my suburban neighborhood. Takes like 7 years for them to, repave the road or whatever. They got construction crews out there working every day. So I don't know. That just holding that contrast in your head when you think about, or you look at like the California high-speed rail projects and compare that to the initial construction of the New York subway in the very early 20th century. Like they had way worse technology than us. Their machines were less powerful. They were more expensive to run, but they were building, dozens of miles of subway faster than we can repave a a suburban road.
Yeah, just to jump in there so I understand it, you're talking about like say 1800s or early 1900s, some of these building projects, and you're saying it's kind of even though we quite literally do have a lot of technological advancements over them, they were just able to do things a lot faster, and they'd often build things that we still find the Empire State Building incredibly useful today, right? So is there
Yeah.
anything is there anything you could say about why you think we might have been able to do things so much faster, say even 100, 200 years ago?
Yeah. So there are a couple of explanations that I don't think they're not mutually exclusive. So multiple of them could be true. One important thing is just way more regulation. So this is something I'm actually researching right now is the impact of environmental regulation, specifically the National Environmental Policy Act. You may have heard of this. It's this law in the United States. It sounds innocuous. It basically says anytime the federal government takes a major action, it should write a short report about what the environmental impacts might be, and talk about, are there any alternatives which could avoid these impacts. But because of some obscure rules and kind of like our common law system of legislation through litigation, these environmental reports, have evolved into these monstrosities which take tens of thousands of man hours to complete. They're thousands of pages long with thousands more pages of appendices. So anytime the federal government wants to, say, give a permit for somebody to construct a new skyscraper or a bridge or a subway, they have to spend literally 5, 10, 15 years writing a report about all the environmental impacts. Of course, nobody will ever read this report except if somebody wants to sue them over it and get them to stop the project. And ultimately, it doesn't even impose a standard of how much environmental impact you should have. So if you write this report and you conclude, well, yeah, the environmental impacts are negative, you can still do it. So it doesn't say you can't do negative things for the environment. It just says you have to write the report, and if it's not detailed enough, you can get sued for it. But if your conclusion is that this hurts the environment, there's no rule which says you can't do it. So it's just a very strange.
Interesting. Yeah, regulations are a funny one because, on the one hand, you might say perhaps we needed them, or perhaps yeah. It's funny too because when we were building, say, things in the 1800s, 1900s, probably was slightly less safe. So do you think that there are kind of trade-offs, and do you think that in some ways that you need some, but we just have way too many?
Mhm.
What you were talking about there kind of sounds like just a massive waste of time sometimes, and that just sort of might be like, okay, that's kind of annoying. That's going to take time and money. Maybe we just don't do the project.
Yeah.
And then, yeah.
Yeah. So I think like there are real improvements in safety. Like we go back to the reference point of the Empire State Building, and I think like 15 people died in the construction of the building.
Oh,
So you see these pictures of New York in the early 20th century, and the construction workers, up on the girders, and they're not wearing a harness or anything, and they're riveting steel beams together. Like, yeah, people fell off semi-frequently. But I think it's possible to, like, we have the ability to avoid those harms without sacrificing as much as we are. So that's one explanation is regulation. Another explanation is something called the cost disease. And this has a very negative name, but it's actually kind of a good sign. Essentially, it's like if you have one sector or some sectors of the economy which are getting much, much more productive, and labor is extremely valuable in these sectors. So you think about like software engineering, for example. Wages are super high, human labor is very, very valuable. because technology is advancing very quickly. It's increasing productivity. And that's some sectors of the economy. If you have some other sectors where there's essentially no growth in labor productivity whatsoever, then this growing, advancing sector is going to try and draw people away. It's saying we can offer you these multi-$100,000 wages to come work in the Google office. It has a slide in the office. You could drink kombucha or whatever. Like they're offering all these perks. So it gets difficult to get people to stay in these low productivity sectors. It's kind of a good thing because like we're getting more in these more productive sectors, but it still means that these low productivity things are becoming more expensive than they were. So for example, like you see these ancient or the Gothic cathedrals with beautiful, intricate stonework carved by hand by, stonemasons. So that would be much more expensive in a relative sense to do today, because when they built, the Cologne Cathedral in 1500, the only other thing those stonemasons could do is like plow fields. But now you have to draw the stonemasons out of, like a civil engineering job where they're empowered with these CAD technologies that can plan entire cities, or you're drawing them out of software engineering, or you're drawing them out of these much more productive sectors instead of like subsistence agriculture.
That's such an interesting one. Like the strangely trade-offs to having good things in good places, and that you could potentially think of a much better equilibrium condition where we develop loads of different interesting sectors, say not just software engineering, and we get loads of cool people in them. But in this, say, route we're down, people get dragged off, say, into software. I'm interested then, we talked a bit about AI near the start, and given that, actually AI kind of underperformed, underdelivered for some years, what does that say as it sort of starts to increase and take off at the moment about our institutions? Is that a good sign, or I wonder if perhaps it's a sign in which actually maybe we put too many eggs in one basket, and so we have growth here but not elsewhere? I don't know if you could say anything about that.
Yeah. So, I mean, yeah, AI definitely will further widen the gap between what we can do in the digital world and what we can do in the physical world. And part of this gap is maybe sort of unavoidable. Like it does sort of get harder to maybe build new things in New York City if there's already 8 million people there. Then it is sort of easier to do it when Manhattan was like an open island than when it's already full of skyscrapers. So there are some inherent limiters to growth in the physical world that aren't present in the digital world. But I think a lot of it is kind of just shooting ourselves in the foot with these useless regulations.
Uh-huh.
And yeah, AI is, I think it will have lots of effects in the physical world, but of course it is a piece of software, and it will be easier to apply it usefully in software.
I wonder what you think of things like the metaverse, or kind of having growth in these areas, because on the one hand, if people really enjoy them and they spend loads of time there, like, can you not? You surely must say that that's growth and that's improvement. But sometimes to me, it kind of feels like kind of distractions, or like, okay, you're kind of making things so that to not actually have fundamental improvements. Is there anything else interesting to say about that?
Yeah, so this is actually I don't my thoughts aren't fully formed here, but it's
Mm-hmm.
something I've been thinking about. Like, there's an important distinction when we're talking about, yeah, say the metaverse is a good word for it. There's an important distinction between a digital world, which is just an extremely compelling, maybe even addictive kind of form of consumption. It's like a form of entertainment, and it just draws people in and it distracts them from more useful things. And then a virtual world where real value can be produced. Like you can exist in the virtual world, build something that other people want, and like create an actual economy that happens online. I mean, we do see this already, sort of, a lot. Yeah, I'm not sure if I'm making much sense there, but
Yeah.
yeah.
No, that makes a lot of sense. Like, I mean, one thing is, video games are really addictive. That's maybe more of an externality than a good thing. And companies that are actually making substantive improvements in things like the metaverse, and it's genuinely better. Or if we have to spend lots of time, to say some of my own opinions, if we do have to spend a lot of time online, say, because we do more work from home, but if work from home just is better for people, because who wants to waste time going to work, and then we just make the online experiences we do have better, like I could then imagine that's actually, like, just in general, like just improvement overall.
Hmm.
On this topic of where can we get growth, and where not. An important part of our global picture is science, and the ability to expand our fundamental ideas and understanding of the world. So you've done some work on this. So how does science academia work, and what are some of its biggest problems?
It's a good question. So I would say that the way that science works today is quite new. It's really like post World War II construction, where there are these huge universities that serve thousands of students, and the professors, like, are there. They sort of teach. They're paid by the university, but they also do a bunch of research on the side. They're competing with each other to get publications in journals and to get grants, mostly from huge scientific funders in the federal government. So all of those things are really quite new in the history of science.
Mm.
Um,
What was it like before that, if I may ask?
yeah, so it's gone through lots of changes. But for example, when universities started, like at the University of Oxford, it would essentially be much more of an independent contract between students and the professors. Like, students would pay their professors individually. Like Adam Smith, when he was going around lecturing, he got paid per student that was in his lecture. It's not like he has a salary. The students pay the university, and the university pays the professors. That's a little more.
Interesting.
Yeah.
Do you think that a system like that could work, or would be interesting to do today?
Uh, Definitely. There's an interesting kind of turn of phrase from Balaji Srinivasan. It's not about science, but it's just an interesting model where we're looking at comparing our current sort of institutions to the past, and we're thinking, well, should we have the current ones, or should we go back and go to the past ones? But it's actually sort of better to think about, instead of you know reverting back to the past, you kind of spiral upwards in a helix. So you're kind of going back to the past. You share some things, but you're not going all the way down the helix and going to the way it worked in Oxford. They didn't have they're lacking in a lot of ways, but we can take some of the things that worked and apply them and build a new system which integrates the best things of the past and the present.
I see. I'll make a synthesis out of them. No, that's helpful. Well, I interrupted you. So would you be able to move from this kind of scientific system where people are doing more individual research, and we have now big institutions, people bidding for grants? So would you be able to speak a bit more about that and how that could go wrong?
Yeah. So the one of the motivating observations which suggests that there is something going wrong is that half of all scientific papers ever published, going all the way back to the very first papers in the 1600s, were published in the last 10 years. But how much of all scientific progress has happened in the last 10 years? It's not nothing, but it's not anywhere close to 50%. So that observation on its own shows you that, well, for each unit of scientific effort, we're now getting way, way less scientific progress. So there are just this yeah, there's this massive deluge of output from science, and that is like useless at best. Um, yeah.
Yeah, interesting. Um, and it's funny you say that because I'm wondering why then we have so much, you could say more science. Like we literally produce way more papers,
Yeah.
but then we kind of in a way get less scientific progress. I mean, sometimes you can think about the greatest. Some of the greatest discoveries were people like Einstein, and you think back to the past. But I also wonder, is that me romanticizing the past? And maybe it was easier to do that in the past, but it's harder today. So I'm wondering why you think we're putting so much more money, say, and time into science, but maybe getting less out.
Yeah, so I'm not entirely sure. I mean, one important thing is that uh, way more money is coming from the government into science than it used to. And, you know, yeah, the government is not very it's not very sort of constrained in the way that it spends money. Like it can unlike say a business, if you have you're running an internal R&D lab, if nothing comes out of it and you're just wasting a bunch of money on these maybe incremental advances or something, like either your division gets shut down by the CEO or you spend so much and the whole company goes out of business. So there are these like real constraints that are constantly um, yeah, forcing them to make a decision or actually do good science. But those constraints are not at all present with federal spending of money. So there's just massive, massive subsidies, like directly through research grants, from the NIH or the NSF, but also indirectly through how much the the higher education industry is subsidized by the federal government, and that's you know hundreds and hundreds of billions of dollars going to subsidize student loans and grants to universities, all of that stuff. So yeah, so it's like we're putting way more in, but the people putting in this money aren't very motivated to make sure it gets spent in a productive way.
Do you think that free markets could work for, say, science or even, say, university funding? I guess we kind of often think that science is, say, a public good, and then we kind of have to give it to governments. But are there maybe alternative perspectives?
Yeah, so I mean, I think that yeah, so like when we talk about free markets, it's not only sort of profit incentive for research, although that is there. Like already there are huge industrial R&D labs. Um, a lot of this is happening in big software companies, but yeah, lots of companies have really big R&D divisions, Google, Intel, that sort of thing. And we've seen this in the past as well. So before World War II, in the early 1900s, yeah, like more than 90% of research funding came from private sources. Some of it was businesses, a lot of it was philanthropy. Um, so yeah,
So,
lots of room
interesting.
for voluntary provision of science. Like I'm not against government funding of science. I think it's one of the better things that governments can do. But I do think that it's a good explanation for why science is so profligate these days, is because they're getting a lot of money with very few strings attached. Yeah.
I'm interested in what you think of the importance of individuals, because you mentioned, we have private firms and they kind of have a profit incentive, so they really need to create something useful or they're going to die. And I'm very interested in the people like Elon Musk at the moment. People who it's almost in a way a bit more like the past. We have people like Tesla, and not the company, but the person who makes incredible things almost by themselves. I'm wondering if you have any thoughts on these people and the way they change history, and whether is there ways we could incentivize, say, more Elon Musks? Like I don't know if you have anything to say about individuals and their ability to change things.
Yeah. It's an interesting question. I mean, definitely the retrospective view is very different from trying to predict what will happen in the future. So retrospectively, it's much easier to pick out a single individual who had a huge influence. But looking forward, it's not clear who that might be, and it's not like we can't really sort of. Yeah, it's difficult to take that advice and then look for those great individuals who will have the largest impact. So looking forward, it might still be the right thing to do to kind of diversify, even if we think that okay, it's just this small group that will have a really big impact. Um, is there room to incentivize more Elon Musk's? Like, I think he's pretty well incentivized already. I mean, what else could like we can't give him any more money, right? He's already reached the maximum. His diminishing marginal utility of money is zero. An extra dollar means nothing to him. There are different ways to incentivize them. I think that we could incentivize more great people with status. And this is something which Elon Musk, like a lot of people hate him, right? And people are very anti, these great men of history. They don't like billionaires. They don't like, lots of people are sort of against eccentric, super innovative characters like Elon Musk.
Yeah.
So
It's something we kind of have to, in that sense, it's almost a cultural change, to give people that do really cool things more status, and you could argue maybe someone like Elon Musk, has it going for him, like, it's probably maybe his fault for his tweets or whatever, but I think in general it's interesting that cool, amazing scientists nowadays, they often don't get enough credit. Like I sometimes wonder, like, why are scientists, not like kind of like superheroes? Why don't more young people want to go? These guys are awesome. And admittedly, in some ways, this is changing. Think about people like Andrew Huberman getting on Amazing Scientists, or I think about myself, or trying to get people excited about different scientists. You mentioned different ways to sort of improve, say, how we could incentivize individuals. You have some really cool ideas about how we could improve academia, or at least try out new things in the field of metascience. So could you talk about what is metascience and what are some ways we can improve science?
yeah, so metascience is it's the science of science. So how do we apply experimentation and theory to improve the mechanisms of science? So this kind of comes back to what I was saying earlier, where a lot of the kind of fundamental institutions of how science works today, especially in the US, are quite new. They're, a lot of it comes from one guy, Vannevar Bush. He founds the National Science Foundation, creates all of these rules and institutions within the government, and those are still going today. But it's not like they ran a randomized control trial. They tried out, 6 different ways of designing the relationship between the funder and the university and the student and the professor. And then they waited 30 years to see, well, which one produced the most impactful research. And then they went with the best one. They didn't do that, right? They just went with what they thought was good. And now we're still there. So yeah, it kind of brings up a question, like, why aren't we experimenting more with the ways we fund science? Why are we just going with this institutional momentum? So that's like one of the motivations for metascience. In terms of proposals, there are lots of different ones going around. Like, for example, some people. There is an effort during the COVID pandemic. Philanthropic scientific funding called FAST grants. And it was this, basically just a group of, some economists and some donators who wanted to, fund researchers like developing tests or for COVID-19. And they just accepted applications, turned them around really quickly. They didn't send them out to other academics for peer review. They just made the decisions that they were sort of the judge, jury, and executioner, and they ended up being extremely effective and quick at funding, for this very important COVID research. So that's kind of an inspiring model where instead of doing, external peer review where you're relying on, anonymous reviews from academics around the country, you can just have a quicker turnaround, like try more things, do them faster, and rely on the intuition and expertise of the employees working at these scientific granting institutions.
What did after the pandemic, fast grants are doing really this fast science and giving grants really quickly. Did that continue after the pandemic? And if not, do you think we can do something like that today? In normal times?
So actually, the National Science Foundation does have a program which is kind of similar to fast grants. It's called they have two. One of them is called, they're both acronyms. One of them is called RAPID, and the other one is called EAGER. And they're both aimed at quick turnarounds, shorter applications, smaller grants, and it's just like I said, where the program officers at the NSF are the judge, jury, and executioner on whether these grants get approved or denied. And so this program exists, and it was actually used during the pandemic to fund research super quickly. But each kind of subdivision of the NSF is assigned, they're allowed to use 5% of their yearly budget through these fast turnaround programs, but they never do. Most of them don't even use 1% of their budget on these programs. So it's kind of strange, like why, they have more autonomy than they're using. Why are they not using this this power to do fast turnaround internal reviews? And honestly, I'm not sure exactly what's preventing them from doing that.
Interesting. Yeah. I mean, I don't want to speculate about that, but one thing in general is, maybe if you do things like this and you give money to people without loads of checks and whatnot, maybe people think, they're not doing science properly. And so I wonder what you think about science having so many checks and balances, and you have to spend so much time applying for grants. And as you've written about, that can often waste scientists' time. And we also talked about individuals, people doing amazing things. So I'm just wondering in general, how can we save scientists' time, and how can we get the best scientists sort of being able to work on great ideas? And is that a problem? Do we need that?
Yeah. So anytime you have an application or a contest for your scientific grant, this is the way that many grants work. They say we want projects on this, or maybe they just open it up to anything, and they accept applications. And hundreds of scientists write a proposal and send it in. Anytime you have it set up like this, you're actually decreasing the amount of subsidy you give to science in total. So because say you have a grant for $1 million, okay, and it's a competitive grant, and you call on scientists to apply, and 100 scientists spend 10 hours each writing their application, and they send it in. But only one scientist will win the grant. So one scientist gets this plus of $1 million to their lab, minus the value of their time they spent, minus the 10 hours they spent writing the application, but they get $1 million, so that's worth it for them. But all the other 99 scientists who spent 10 hours writing the application, they're just down 10 hours of their time. And if you add up the value, all of those hours lost, it can rival or exceed the total increase, the total subsidy you actually gave to science with the grant. So you do get better targeting with a contest. You can read all the applications and choose, like, this one is the most promising, so I want to subsidize this and not the other ones because this direction is the most valuable. So maybe, it depends on a lot of specific factors, like how good is this targeting relative to the cost that you get from this application. But so funding science, one way to avoid this is like the MacArthur Genius Grant, for example. They just have a committee which picks people to win. and they just give them $1 million prize. No one applies. They just look at their work and say, who needs this, who deserves it, and they just pick them. So there's no sort of cost to the scientists there. And it's a different model that has advantages and disadvantages, but that's just something to consider when you're like designing mechanisms for science. If you have this competitive application, you're gonna be working against this headwind of the cost that everyone invests into the application.
And you know, along similar lines, you've also talked about before ways in which we can distribute grant money sort of to scientists themselves. You wrote about it in an essay competition that you came second place in. So would you also talk about this kind of interesting idea you've had about how we could distribute funds to scientists rather than having them apply for, make grants?
Yeah. So the idea, it's not something, there. Yeah, so I'll just explain the idea and then qualify it. So it's called, I called it researcher guided funding, and it's simple idea. Essentially, just like take all of the say researchers at R1 universities, which is just this classification. It's like the ones which spend the most on research. It's like several 100,000 scientists, and then take the annual R&D budget of the United States. It's like something like $100 billion, and just split it up and send it out in chunks to all the scientists. I think I calculated it's like $500,000 each, something like that. And say, 50% of this money you can keep for yourself and use for your own projects. 50%, the other 50%, you have to use as a grant maker yourself. Find somebody else. It could be your colleague. It could be somebody across the world who you think is doing good work, and give them that half of the money. So this kind of takes advantage of the distributed knowledge of scientists, and in a way, right, it's not so different a bit from what already happens, because right now, the NSF receives an application, and then it like sends it out to 6 university professors and asks which of these applications should we fund. So that's kind of working in the same way, where it's just aggregating the opinions of these professors.
Interesting. I'll keep going.
Yeah. Like, this is not a completely serious proposal. For example, there's a huge problem in that it's kind of this arbitrary cutoff which decides who gets this $500,000 a year, this R1 classification. So if you just assign that as a cutoff, there's now huge pressure on this classification, and it will immediately be changed, and people will clamor to be chosen as an R1 university, and like the institutional design wouldn't work out. So it was mostly just kind of a thought experiment. Like, here's a different vision for something we could do, and it's
thank you. No, thank you. Yeah, and it's and I mean one thing as well, and as you've touched on as well, is why not experiment with these kinds of things? Like, as you say, they're like practical things we need to like keep in mind. But we've kind of just sort of gone down a route in science, and it's like, maybe there are better ways of doing it. It's funny, like $500,000 for each scientist. Like, I'd assume, like, say you're an economist, I assume you don't need that much like money to do. I wonder, are there different projects or different work in science that requires way more funding, if that makes sense? And I'm wondering what kinds of scientific projects are like most impactful, and where we kind of want to get the money to.
Yeah, I mean, there's the ranges from like, okay, you're an economist, all you really need is like a laptop, versus, okay, if you're like an experimental physicist, you need the large Hadron Super Collider, right? So it's really a big difference in how much money you need. Yeah,
interesting. I think moving away from science and zooming out, an important part of economic growth that kind of all taught about is we need ideas, and we need people to make ideas. And I wonder sort of in terms of demographic changes in the world. We have a lot of areas of the world with really high population growth, but it's also kind of known to be a problem that the declining, population, say, in the Western developed world. So I'm wondering what you think this might have an impact on in terms of future growth and continuing to improve productivity and sort of stay on an increasing trajectory.
Yeah. Yeah, to be honest, I find these demographic trends very worrying and strange, to be honest. And like, yeah, I have few things to say about that. First, I would just observe that it's like almost a kind of cosmic irony and cruelty that the richest and safest and most prosperous places on Earth have the lowest birth rates, and the poorest and most dangerous places on Earth have the highest birth rates. And like, and yeah, if we could just switch those numbers, like I don't think we can switch those numbers, but yeah, it's just strange to me. Especially,
Yeah,
yeah.
yeah, it's funny.
Uh,
Keep going.
Yeah, so then the other thing I would say is just from a more kind of technical perspective from economics is that the best models of economic growth, ultimately economic growth comes down to population growth. So there's like um, you know labor and capital, and there's ideas, and all of these combine to create economic growth. And capital is just constrained by the size of the economy and by depreciation. So you can really only have so much capital before it gets too expensive to maintain. So that's like capped. If the other things don't change, if labor and ideas don't change, then capital will reach some finite limit. Okay, labor obviously depends on population in this important way. Uh, you know, we can augment it by yeah. So we can like labor is ultimately dependent on population. We can augment it with ideas. We can make each unit of labor more productive by discovering technologies, by giving people more machines to work with, and ideas ultimately are also produced by people. It's just a special set of people. Maybe they're called researchers or something like that. But uh, we can send more people to college, make more people researchers. But again, if population growth is capped, then there's only so much we can do. So I just think that's interesting, and it's something that I wasn't really taught. I just had, I just went through and read these papers and noticed, yeah, like ultimately they're saying it all comes down to population growth. Um, One kind of way out of that is if we can make a machine which makes ideas. Like that might be some artificial intelligence. It's a little speculative, but yeah, that's
Yeah, a very interesting one, and I guess if that happens, it's like kind of hard to say what other things that technology does and what that means for the say need for human beings and like what kind of our values are. I talked to Robin Hanson, the economist at George Mason University, and he's focused on population growth a lot. And it's funny you mentioned that in the developed world where we can support more children, right? And at least in our minds, give them better lives. We decide not to have them, and it's very complicated, and there are many things to say, but one thing I actually wanted to ask you is about because Roman Hansen talks about us fearing the future, right? AI does and already is having lots of benefits, and there are many new technologies which are having benefits. But in part, he kind of argues that actually we're just more and more seeing the downsides of the future, right? It's not that we're scared of any one thing like AI, we're just kind of scared of change. And I wonder what this does to our project of greater prosperity and greater technological change. Like, is it right that we should be scared of change in technologies? To what degree should this sort of advocate should we be an advocate for technological growth? To what degree is it good and bad?
Yeah, so it's an interesting question. I mean, I personally am definitely an advocate for technological growth. And yeah, it's based on this historical perspective, which is like I said, at the center of everything I'm researching and writing about, that we're in this strange position at the top of our hyperbolic growth curve. And like nothing that we have today, very little of what we have today, would have been imaginable to somebody 300 years ago. And, somebody 300 years ago, let's say they were living a good life by the standards of their time. They were respected in their community. They had their family and things like that. And you would ask them, like, should the world, like, if you tried to explain to them how much the world would radically change over the next 300 years, they would probably fear it. And they would say, we don't need that. Like, I have a good life. And that's kind of how I feel. Like, I'm extremely lucky. I was like, by no influence of my own, I was like just born in at the top of this curve in the richest country and the safest country, like born in the United States. So I'm just like so lucky. I feel very content with my life. But I don't want to say, oh, well, that means we can just stop here. There's no reason to go through this radical change, which is scary, because that's exactly what somebody, way further down on the curve would have said. But then nothing that we have today would have happened if they had gotten their way. Yeah.
Yeah, that's a really interesting take, and some people today kind of also talk a bit about expounding the benefits of the past, like, oh, maybe people worked fewer hours, and there's overwork of people now, and do we actually enjoy, like, say, the greater consumption that we can have? So I wonder what you think about people perhaps romanticizing the past, and is it justified, and is it true? Yeah.
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 I mean, like I think there are lots of responses. Maybe a kind of a pithy one I could give is that the past is still available if you want it. Like, you could just go out and live in the woods and have a subsistence farm and break your back every day, like plowing the fields if you want. But nobody wants that. Nobody does it. Or you could go to Papua New Guinea and be a hunter gatherer there, deep in the jungle, and that's what humans did for a long time. So if you think it's so great, like, it's still there, why don't you go and take it? I think it's because the modern comforts are very valuable.
Interesting.
Yeah.
I think sort of a kind of final topic I wanted to touch on, and then we'll close this out. I really appreciate your time here. Is what are, like, the kind of practical and political challenges to implementing ideas to, say, improve growth and to keep on sort of keep having high growth rates, right? We can talk about really cool, interesting ideas, but I'm wondering what practically would need to happen to implement some of these ideas.
Yeah, it's a good question. So one thing which still confuses me is how homogenous the regulatory regime is across all the governments around the world. So, like, wherever you go, there will be the same conflicts over, like, zoning and historical preservation laws, which are, driving up rents in big cities. Some places have it better than others, but, like, the conflicts are very common. They work the same way. All around the world, countries highly regulate their energy industry. They highly regulate, like, nuclear energy in basically the same way. They have highly strict like medical regulation, just like the United States. So there are all these, like, I say them as low hanging fruits. We're sort of shooting ourselves in the foot in these wide variety of ways. But no one is really jumping at the opportunity to get around these things. So it doesn't really
Yeah.
answer your question, but it just suggests that whatever explanation there is for why it's so difficult to, or like what challenges we face when we're trying to get these reforms, it has to explain like the global homogeneity in the problems, and like everywhere is facing very similar problems in this respect. Yeah.
Interesting. Yeah, it's kind of deeper than like not only are there changes we can make, but as well there are kind of just issues that we could, that people kind of even acknowledge their issues, but we don't solve. Robin Hanson, the economist, again, just because I talked to him recently, talked about the process, something called rot, which is like in software you build something and it's really difficult to change. It gets so complicated, and sometimes I wonder whether it's academia or broader institutions, we build things up and they get so complicated and they work to a degree, and so even though they're not perfect, it's kind of what we get stuck with. So yeah.
Yeah. So maybe just another thing I would say is that a lot of the big advances in our institutions uh, didn't come sort of as reforms. They came as like startups, basically. So they weren't kind of like to bring the analogy back to software again. It's not like they were taking some existing code base and then changing it. They were like making a new piece of software. So like you think about the founding of the United States. That was like the last really big and successful startup. So that yeah, that suggests something about maybe there needs to be an exit from the current system to make big progress because of exactly what you're talking about. There's just too much already built up elsewhere.
Max, where can people find you and more of your work, and do you have any last words to say?
Yeah, so I'm on Twitter, Maxwell Tabarrok. You'll find me, and I've got a blog, Maximum Progress, where I'm writing and thinking about all the things we've talked about today.
Awesome. Yeah, thank you very much.
Yeah,
Appreciate
thank
it.
you. This was fun. See you, Jack.